So this is my invitation to everybody wear this suit. It's covered in about 24 to 36, depending on if I've lost any, little spheres that are covered with retroreflectors. And in a moment, you'll see how we're using those. So the Immersion Lab in MIT Nano. So tomorrow is our sneak peek, but let me tell you a little bit about that. You can go to the webpage. If you go to immersion.mit.edu, we now have that as our URL. That'll link you over to MIT Nano's webpage that talks a little bit about all the things that we're providing inside of the Immersion Lab at MIT Nano. It's a very flat display. You can go read that. Or, if the clicker works, there we go. So right now we're standing outside of Nano. You can tell there's something a little unusual going on with the little blue dots. Looking around. Okay, I'm going to go walk inside of Nano here for a second. I'm not sure where I am. Oh, okay, let's see. Where am I with respect to Nano? So this is far more realistic if you were wearing a heads-up display. But we were able to capture 3D scanned imagery of all of MIT Nano, both inside and outside. We're now walking down the halls in the entranceway to MIT Nano. You'll see on the directory there for a second, third floor, the cave. Before we opened the Immersion Lab, originally it was called the cave, but it's now called the Immersion Lab. So if you're looking for the Immersion Lab, you follow the directions to the cave. So let's go to the third floor. Okay, we just teleported up there. We're sitting in the little lounge area between building 13 and 12. And took a zoom back, cleaning room over there, orient where I was sitting. Go down around the hallway, and I want to work my way around MIT Nano. So first, okay, I'm on the third floor now. We'll just double check, make sure that the Immersion Lab hasn't moved. Okay, it's still there, the cave, third floor. So let's keep going. We'll pause in the moment, as we like to call this space, and we'll take a look up at the dome. Nice bird's eye view there. Let's take a zoom out, zoom around real quick, just accelerate our path down there. Orient ourselves down the hallway. Hit go. Here we go. Walking down the hall, parallel to the infinite corridor. If you look carefully, you can see the cameraman that helped take all the photography there. So conference room right there on the right. Turn the corner, and we're just about the entrance, to the entrance to the Immersion Lab. Okay, so now let's go into the Immersion Lab, or let's talk about a little bit how we came to decide what we should put into the Immersion Lab for the first set of capabilities that we're making available to the community, the MIT community, collaborators, as sort of the model for the rest of MIT Nano. It's a phenomenal resource. Let's talk about the resource that is the Immersion Lab. So Megan Roberts, I'm not sure if she's here at the moment. I see her hand in the background, so she's waving back there. Has been leading a outreach effort across campus to understand what should be in the Immersion Lab. What are the set of capabilities that we should have there to interact with MIT Nano in terms of being able to visualize the data that's coming out of MIT Nano, to be able to visualize the production data, if you will, or when we fabricate, or to visualize the metrology data on the Cryo-Electron Microscope. Or broadly, what does the MIT community need? What are the resources that we should put inside of MIT Nano that are prohibitively expensive for one other single investigator to purchase and to use? So we've had, and we will continue to have a series of outreach across all the schools. Megan's identified a number of very interesting interests. And I would say this is not the final list, but this is the place that we're able to get started. People are very interested in using VR, virtual reality tools that conduct experiments, developing novel technologies for AR and VR applications in medicine, in manufacturing, in design, and blending the physical and the digital world. So what that means is sort of having technology that allows us to capture motion, which is why I'm wearing this thing, and to be able to visualize data. A number of interesting questions. How do we use AR and VR for education? Should we have an open courseware edX style of pedagogical content that's aligned with using AR and VR technologies. There's a lot of undergraduate and graduate student interest that would just like to play. And we're constantly seeking advice on what we need to incorporate. So we'll see in a second what we do have, and the sneak peek starting tomorrow and Wednesday, you can see more. So we'll have a lot of displays. This is one of several types of head-mounted displays, fully immersive experience, virtual reality. You'll see sort of the displays are in front of your face, the ability to track where these things are in space. And you'll see Vladimir actually up in the Harvard facility interacting with, I think it was NanoMe, to be able to visualize molecules and things at the nanoscale. So we have technology that you can immerse yourself into virtual reality environments. This is not me at the moment, but why is that interesting? So Elazar Edelman, for example, teaches a class here in physiology, and they'll want to be able to demonstrate, for example, what the normal heart looks like and pathological cases of the human heart. When doing a biopsy or doing a cadaver study, it's typically easy to find good healthy hearts. It's not always easy to find the sort of the non-healthy heart and be able to convey what it looks like when a normal heart is beating. Or if I want to zoom into the human heart and understand the vasculature, understand the valves, understand how things work, you can get one level of familiarity when you're doing a dissection, but you can get a whole new level of familiarity if you can take data, in this case the human heart, or data that's coming out of the metrology tools, and bring it up to the human scale to see the textures that here are micron, or tens of microns of size features, but to put those at human scale, it appeals more to some of the intuition that we may be able to gather when looking at data. Okay. Here we go. So we have some of the first tools that we enabled inside of MIT Nano, 2 new Cryo-Electron Microscopes. We have, as I like to say, the biggest of big data challenges. So this tool will generate over 4 terabytes of data in 15 minutes, and it should be booked nonstop. So we'll be generating petabytes of data in a nonstop clip with one tool. Now when we turn on the 12 imaging bays, not every tool will generate so much data, but we have a big data problem. And how do you manage, how do you visualize, how do you manipulate? MIT Nano, the Immersion Lab, certainly provides an entree point to the computer scientist or the graphic artist, or people that want to understand how to manipulate and visualize and interact with data. And as well, we have the machine learning aspect of, well, how do we robustly compare data that's coming from a gold nanorod today, or if it's aged and looking at it tomorrow or 6 months, to be able to robustly compare multi-dimensional, multi-spectral features robustly, easily. It's not like when a new graduate student comes on board and you're sharing a Word document, you just copy and paste it. You don't copy and paste 4 terabytes of data. So some of just the data plumbing are some of the really interesting research questions that are generated because of MIT Nano. This is just a graphic that maybe gives a little bit of explanation for why the cryo-electron microscopes are generating so much data. So this is taking a sample, same way that you would do tomography, looking at a sample under different orientations and looking at imagery through, creating an image projection through a thin slice from many different angles, and then bringing that all together so that you have now a volumetric, there we go, a volumetric representation of biological structure or of material structure that now you're not just constrained with looking at it on a flat display, but you can bring it into either a heads-up display or something that's out at human scale. Okay. So it can't just be all heads-up displays. This was we borrowed some hardware from Sony, and we had a very small, TVs grow when you get them home. Well, this one didn't grow quite enough. We're in the process now of designing and going through the process of figuring out, well, what is that full immersive display that goes on the entire outer wall? So this is in design, and that will not be in the sneak peek, but this is something that will be in the Immersion Lab to come. Okay, so that's on the visualization side. We envision the visualization capabilities being a combination of both very large wall-mounted displays, singular big screens, projection or monitor, and then also a number of different technologies for head-mounted displays. Now this is why I'm wearing this suit. This is a rail system that has cameras around the outside. And I'm wearing a suit that just makes it really easy for those cameras to detect the features that are on me. And we can do either biomechanics studies as elucidated in the bottom, or have multi-actor, multi-people working around in one immersed physical environment. One of the important things, and it came up earlier today, when you're interacting in a virtual space, the sensors that you need to know where you are, how you're moving, to be able to keep track of the physical orientation between your data representation and you. If I want to physically interact with data, I need to know how I'm moving to interact with that virtual thing. Otherwise, if there's a disconnect, if there's lag, that leads to the motion sickness and things that sometimes virtual reality has been known for. So we need very robust abilities to track motion. This is the Immersion Lab before, when it was almost empty. We have some floor tiling on there. Going through the process of installing a rail with bunches of different cameras. Each one of these cameras has its own illumination source, so that now, you can wear this suit. You can come into the lab. This is just tracking. It was a good stress-relieving day for me. Just spinning on the chair. All right. The 3D representation. So I have these markers on my elbows, on my head, and then sort of on the joints. And then you need them at least one place between the joints so you can get the rigid body translation and rotation of your various limbs. Okay, so if you ask nicely, we'll let you juggle these $500 balls that really aren't intended to be juggled. But they are, instead of wearing the suit, again, they are these little objects that can be tracked through space. Understand the dynamics here of how those things are moving around while I'm juggling, so we could quantify my ability to juggle. Unfortunately, at least in this video, I didn't drop anything. And so Tom offered, he said for $5 if I did this if I did it on stage now, he'd give me $5. So I don't know if I'm going to do it. But you can get all the types of motion that you would want in terms of doing biomechanics studies. But now, why is this important for visualization? If I'm wearing a head-up display and I want to reach out to a piece of data and it's physically located at this place and I have other people in the room, I need to know how things are moving around. Right? So it's a combination of visualization and motion. So as we said, we're continuing the outreach across campus. We've certainly identified a core group of potential users. There's a major need just within inside of MIT Nano to support it and the things that we want to do for training and visualization of data, and then reaching out broadly across campus to identify those other areas of interest. It's a big box. It's a 28-foot cube. The equipment that's there now, this full motion capture system, anti-latency floor for doing even faster tracking of the head-mounted displays, lens cloud, which I'll have up in a moment, different types of head-mounted displays. And the things that are paled out in the bottom are things that are in process, the data infrastructure, the compute infrastructure to be able to process data, and the full wall display. Okay, so the sneak peek tomorrow. Please come by. We won't be able to have 200 people in the room at once. I think fire code tells us we can have 49. But we'll have a series of demos throughout the day. And we're really looking to identify the community of users that can further inform what we should be doing, the hardware we should be buying, and the infrastructure that the MIT community and our collaborators will be interested in having. Okay, just want to highlight already there's an ongoing sort of emergent collaboration between IMES. IMES is the Institute for Medical Engineering and Science, very interested in the healthcare and the biomedical applications of being able to do biomechanics analysis, tracking people in the home, as Dina was talking about earlier. So there's a nice intersection between what IMES is trying to do over in building E25 and what we're doing in MIT Nano. Okay. We heard from this morning from NCSoft. NCSoft has graciously provided not only some seed funds to launch various projects on campus, but also provide the capability to provide or to purchase equipment to help us to originally outfit this space. Okay. The last thing, so this is the lens cloud. So I'll just go right to the actual image of it. The lens cloud is a very rapid way to do 3D scanning. It's, I forget how many cameras and how many illumination source, but you walk into the cylinder and instantaneously, in effect, it gets the data to be able to create the avatar of me, or if I need to scan a couch, or if I need to scan a small animal. If I want to scan anything, it can instantaneously get that data. It takes some time to process it, but we'll end up with a 3D and virtual model. And so if you're willing, you can come step into the Lens Cloud during the sneak peek tomorrow and on Wednesday. So we're open. So come on by. It'll continue to evolve. And this is at the bottom, the MIT was our very poor attempt at trying to spell out MIT with our bodies. But with that, I'm at 0, so thank you.